right, let's go ahead and get started with today's event. Welcome to our webinar and virtual panel. My name's Steve Boals, and I run business development for Ephesoft. And I've asked a couple of my company mates to join us in a new format that we're trying, the virtual panel, to talk about Ephesoft's artificial intelligence and how we can help organizations drive productivity in accounting and beyond. So if you're not familiar with Ephesoft, quick infomercial, been around since 2010. We're an innovator in the intelligent document processing space. We've got a few products under our belt and about 1,000 customers across the globe. So that's the end of the infomercial, and we'll get to the panel today. So I will be guiding us on our journey, and these are my two partners in crime. Kevin, you want to introduce yourself?
Yeah, thanks, Steve. So yeah, this is Kevin Harbauer. I'm the CTO at Ephesoft, where I lead the development and product direction for our portfolio. I got a pretty diverse background across development, IT, DevOps, a variety of things, including data and security. So kind of excited to be here and chat with you.
Great. And David, you want to introduce yourself? I think you're on mute.
Yeah, sorry, I got muted by our host. Can you hear me now?
Yeah.
Yes. Great. So I'm the handsome one on the panel, as you can tell from the pictures. But I'm the data science team lead here at Ephesoft. I work with our data scientists to prototype and our engineers to bring our models into production.
Great, thanks. And I'm Steve Boals, your host. Been in the document processing industry for about the last 18 years, and I'm really excited about what we'll show you today. I brought this to life in conjunction with Kevin and David, just because of the really neat stuff that we're doing from a technology perspective, and I wanted to share it with you guys. So a few weeks ago, internally at Ephesoft, we had a product update session, and David gave a really good presentation on the technology behind our new cloud-based processing engine, Semantic. For those of you that don't know, Semantic is a cloud-based document AI platform for driving automation and productivity. And I thought we have to provide this information in a different type of forum. That's why we're here today. So we're showing some really impressive results with our first use case, AP invoice processing. So we wanted to talk a little bit about accounting and what we're doing. So AI is finally hitting the mainstream, and organizations are really starting to see broad benefits of laser-focused solutions to solve specific problems. So this chart from Deloitte sums it up. Making complex processes more efficient leads the pack when it comes to objective for AI projects, and also tied to their true outcomes. So accounting processes are ripe for improvement, and putting the invoice flow on autopilot can be a key to freeing up staff and really reaching maximum efficiency. So before we get started, I wanted to show the Gartner hype cycle for artificial intelligence. If you aren't familiar with this graph, it shows the rise and fall of technologies through a cycle from innovation all the way to maximum productivity. Many of the topics we'll discuss today are rapidly sliding down that back slope of the curve that you see highlighted here in red. Here at Ephesoft, our team has really surged ahead of the pack to provide AI that's hit the upslope. As we cover later in the panel, we also have a team innovating with knowledge graphs and decision intelligence, which will be coming around the corner pretty soon. So now that we have a quick primer on some of the facets of AI, let's get started with our discussion. So for our first question, there seems to be a lot of confusion on the topic of artificial intelligence what it is, what it does, and what it doesn't. Also, what true machine learning can accomplish. So I think before we get into the kind of the meat of the presentation, we've got a few questions to ask. So Kevin, what is your definition of artificial intelligence?
Yeah, you make a great point. There is a ton of confusion and hype around AI these days. You know, a lot of companies and products advertise, you know, their use of AI, and it seems to be used kind of interchangeably with this idea that something's smart or able to kind of learn. But there's a lot more to it. You know, AI really refers to kind of the science and technology, which is focused on, I guess, replicating human intelligence, right? But, you know, a lot of the times what we're trying to do is, you know, automate tasks or do something by mimicking, you know, human intelligence in computers. And, you know, at the end of the day, it's AI is really just software that we use to make some intelligent decisions or some accurate predictions. And despite the hype, a lot of the techniques and the foundational algorithms and learnings haven't really changed much in the last few decades. I think what's happened and why you're seeing this explosive growth is, you know, it used to be, unless you were in academia or, you know, one of the big companies that had access to huge amounts of computational power and data storage, you just couldn't process the data and fast enough. And so the, you know, cloud services and GPUs have kind of democratized it. And so I think that's why we're seeing this growth and as a side effect, this confusion around AI.
Sure. And another term, machine learning. So David, what is machine learning and how's it tied to AI?
Sure. So machine learning we could think of as a subset of artificial intelligence. And you know, as Kevin was saying, artificial intelligence has kind of changed. It's a moving goalpost to a certain extent. And that, you know, once we were able to perfectly recognize pictures of cats versus dogs, people started to throw AI out a lot. And now the new sort of general intelligence is AGI, artificial general intelligence. So can we do all the tasks humans do well? And so machine learning underneath all of that is really the statistical approaches that we use to learn patterns and representations inside of data. So it's just that smaller area that's focused mostly on the math, the algorithms, and the statistics behind teaching machines to do a task very well.
That's great. Okay, so we cleared that up, and we're all on a level set now for the rest. For those out in the audience, the format you'll see, we'll ask some questions, and then I'll give you some interesting statistics and information from out in the market. I love these 5 myths of AI from Gartner. If you look at them 1 through 5, you've probably seen them or heard them out there or read them in different articles. We'll dispel some of those myths as we go through our content slide to slide. So our next question, David, what does a data scientist do?
Yeah, so the term data scientist is somewhat of a nebulous term. It can be applied in a number of different areas where, you know, as a sector in general in machine learning, we're still figuring out exactly what we do. But I like to think of us as kind of 19th century prospectors, so to speak. We're looking for gold. And we have these mountains of data in front of us, and some of it's usable, some of it's not. But we have to go mining for it. We have to dig through, and we have to find that gold ore. And then we have to take that gold ore and we have to process it, refine it into beautiful bricks of gold. And that's kind of what we do, but with information and data, is we take that raw data, all of that raw information that comes into our systems, and it just continues to increase every day. And then we have to refine it down into a usable format, because ultimately we're looking to provide good business intelligence. We're looking to support different departments within a company using actionable insights, really, to say, based on all of the data we have, this is what we should be doing, or this is how we can improve our processes. And so we really distill down that into a single piece of actionable knowledge.
Okay, that makes sense. And Kevin, what's the value of a data science team here in 2020?
Yeah, I think I'll just kind of follow on David's analogy there, and you think about mining gold and turning it into something valuable. We've been pursuing that as a humankind since probably the dawn of time, and while the goal has always been to turn it into something valuable and pretty, how we've gone about that has changed. And I think it's the same thing with data science. We've been working on data since probably before the computer age, and the concept of AI has been around for 50 years more. And it's in the past we might have called things like knowledge discovery, or we built decision support systems, or maybe we had a business intelligence team. But the main goal was always, how do you extract some meaningful patterns from the data so you can get that insight and make a decision, and hopefully put you at some kind of competitive advantage. And that value really hasn't changed. It's the techniques we're pursuing now are what has evolved.
Okay, understood. Let's move on. So I love this stat from IDC, that machine-generated data will grow to encompass more than 40% of the internet data in 2020. If you've seen some of the projections on growth of data, that's a pretty amazing statistic. The machines are almost ruling the data sphere. So now we get to a little bit about us and our AI. So the first question is, Kevin, can you tell us, what is semantic?
Yeah, let me start with kind of giving you some context, and you'll probably hear that word a little bit throughout this, but what drove us to come up with this idea of semantic and this new product, and where it kind of started from is, as we watched and were involved in many of these data transformation projects and RPA projects, and despite this huge investment across the globe by enterprises, it's a surprising number of these projects fail. And as we dove into that, one of the common themes is a lot of these projects pursue it, as a data problem, right? It's like, how do I move this bit of data from one system to another? And they lost sight of how to solve that ultimate goal, which is productivity or becoming autonomous. So we wanted to take a step back and look at how we could take a more modern semantic approach to solving the problem, and see how we could leverage concepts like linked data and knowledge graphs to provide workers, this is both either human or digital workers, the context or knowledge they need to perform a specific task and truly become autonomous. And so that was, the driving force, one of the driving visions behind semantic. And, at the same time, we were looking at how do you bring the power of cloud computing and AI to help solve this challenge. And so as we built out the first use case, semantic invoice, we focused on how to deliver a solution that was low code, no code, to try to maximize the time to value, and solve this bigger productivity problem.
Okay, great, great overview. And David, how does AI fit into that, and how is it used in the semantic platform?
So I think the better question is, how doesn't it fit into the semantic platform? We've integrated it into almost every part of semantic. We're using neural networks, random forests, a lot of the really well-known machine learning frameworks, architectures, and models. And we're using them sort of where they fit best, because we're tackling natural language processing. We're working on the text of these invoices. We're using computer vision. We're looking for visual cues in these invoices and how they're structured. We're using statistical analyses to help us refine results and improve performance. I mean, all of these different pieces are fitting into semantic to deliver ultimately what we hope is going to be the best and continually best product for document processing.
Great. Yeah, and speaking of best, we'll talk a little bit about some of the accuracy numbers as we get towards the end, and the types of accuracy levels we're achieving. You know, in my prep for this, I talked with David, and I've talked with several of the data science team members. It's amazing. We had the benefit of having been in the capture industry for a very long time. We've got a lot of sample documents. They used over 150,000 samples to build this AI model for invoice processing. And that large sample set really shows in the results, which we'll, as I mentioned, we'll talk about later in the presentation. So we talked about all the noise about AI. Everyone claims they have it. It's alive and kicking in corporate environments. True or false, Kevin? Does everyone really have it?
Well, I think the answer is actually it depends. You know, I saw a report earlier this year that stated only 29% of companies are using AI, truly using AI. So it's definitely alive. It may be starting to kick, but clearly not everyone has embraced it. Yet at the same time, what's interesting is the companies that are embracing it, you know, they're definitely growing at a faster rate and being more successful. On the product side, I think it's a little murkier. I think a ton of products claim to have AI today when they don't. You know, one of the more well-known cases, you know, from years past was a startup that was claiming to be a robo bookkeeper. And it came out that they were really just using a bunch of offshore accountants in the Philippines. You know, and maybe that was their MVP approach. But, you know, and to their credit, today they are using a lot of AI. But, you know, as a buyer or a consumer of technology that, you know, claims to use AI, you really got to get under the covers and understand what's going on there. But there's no doubt that those organizations embracing AI are going to be more successful.
Yeah, that makes sense. And when we look at that, you know, everybody says they have AI. David, from a data science perspective, doesn't everyone use the same exact foundation or algorithms within AI? How does that work?
Yeah, so it's a bit of a leading question here, and if you'll permit me to use more bad analogies, you know, I think, you know, the statement that everyone uses the same algorithms is a lot like cutting down a tree. So if you give somebody a Swiss Army knife, there's a tiny little saw tool in there that, you know, you could use to cut down a 100-year oak tree. It'd take a long time. It'd be really hard, but you could do it. You could also give somebody a hand saw, and they could, you know, cut down the oak tree a lot faster. You could give somebody a chainsaw, which obviously they would probably much prefer. Or you could even go as far as giving them a harvester processor, you know, a giant excavator with a huge saw on it. And I think this is sort of what the machine learning area is like between competitors, where it comes largely down to what's driving your product. You know, is it a few muscles in your arm that's cutting down with a Swiss Army knife, or is it a massive excavator diesel engine that's driving a chainsaw to cut down, you know, 10 trees a minute? And all of that is really based on data, right? So what kind of data support do you have behind the model? If it's not good, you're not going to have a great model. There's a lot of proprietary architecture decisions as well that, sure, it's the same algorithm, but how you tweak it, refine it, add to it, or change it fundamentally can really have a large impact on performance. there's also additional model support utilities and code that can go into this, how we pre-process data, how we post-process data. There's so many individual components that support the basic algorithms that we can really get a wide variety. And sure, they might all cut down a tree, but at the end of the day, which one are you going to really trust to get the job done?
Sure, that's a great analogy. So I thought this was interesting. I was doing some research for the panel and looked up MIT Tech Review, and a while back, they actually went and polled 400 companies in Europe that claim to be AI companies. 40% of them had no artificial intelligence at all. So it's really a pervasive term that's misunderstood and misused. And hopefully we're bringing some clarity to some of that and what's happening out in the market. So any relatively new technology comes with baggage. Let's talk challenges. David, what is your biggest challenge in building these models for processing documents?
Sure. So probably the biggest day-to-day challenge I face is just dealing with Kevin for the most part. No, I'm just kidding, Kevin. So actually, probably the biggest challenge is data. And I think anyone involved in machine learning or data science can appreciate that, there's so much data coming in that gathering it and sanitizing it, annotating it or making it usable, labeling it, there's so many problems associated when the volume of data is that large. Even if you have a team of people working on it, you get annotator fatigue and disagreement between annotators. And so it's a tough problem to solve. So we've spent a lot of time developing tools to assist with these difficulties, such as using neural network self-supervision, where we can utilize unlabeled data. We're using transfer learning across documents so that we can reduce our need for labeled data. And all of these are sort of, assisting us make use of the data as well as build up our fully annotated and labeled data stores. But it's a day-to-day challenge that we're constantly finding new problems to deal with to maximize our performance.
Okay, great. It's all about the data, right?
Sure is.
Kevin, from a CTO perspective, what are your challenges?
Yeah, I think, and even though David kind of joked about, having to deal with me, the people side of things, he brings up an interesting point, because it's, there's always technical challenges, but as an organization or an enterprise starts to contemplate that build versus buy decision around whether, how to bring that AI into their enterprise, the people side of it and building that data science team is probably going to be one of the biggest challenges, because in addition to data scientists like David, you need, data engineers that can clean and annotate and transform your data. You need, information designers that can kind of bring to life the visual aspect of the data so that your users can get the insights. You need machine learning engineers. So you need this really diverse skill set. And we haven't even got into all the technology they need to bring to bear. And so, as you ponder that build versus buy on how to bring AI into your organization, I think the people is probably one of the most critical challenges to solve.
Interesting. So we're not the only ones that have challenges, right? It looks like 8 out of 10 organizations have had their project stall for a variety of different reasons, and I've got a great chart and a couple of slides that'll show that. And on the data topic, 96% have said they run into problems with data quality, labeling, and building model confidence because of that dirty data. So once again, all about the data. So I hear that I'm just a sales guy, but I hear that building models and running them requires some serious horsepower. They talk about GPUs and other types of processing. Let's talk about what you need and where you run AI. So Kevin, what do you need to run these models and make them do their magic?
Yeah, I think there's two things I want to kind of maybe touch on here. Is you're definitely right. You definitely need some serious horsepower. Although that's evolving. People like Facebook are figuring out how to run some models on phones. But in the enterprise today, you still require some serious kind of horsepower, and so that means you're looking at either how do you bring cloud computing into your organization, or you're making major capital investments to bring the GPU type computational horsepower and all the data storage into your organization. And as you kind of make those decisions and you move into the cloud, your next hurdle becomes data governance. And a lot of times you're processing sensitive data. And so, this is where the whole compliance and data governance kind of runs headlong into the AI world. And so figuring out your security posture and making sure you can process your data in the cloud in a very secure way is going to be kind of critical moving forward.
Sure. David, cloud or on-prem or both? What can you run these models in both environments?
Yeah, I'd absolutely have to say both, but with an asterisk that we'll discuss here. Cloud obviously has a lot of great benefits. It offers the power and adaptability of continually updated hardware. You don't have to manage any of the server racks. You don't have to have a special person just dedicated really to keeping things up and running locally to provide that power, which is great from a data scientist perspective. We no longer have to worry about maintaining those servers. We can just use the cloud for a lot of our training and data manipulation. On-premise obviously has other benefits. As Kevin was mentioning, maintaining data flow and ownership is a big thing, very fine-tuned control over the process. And obviously the cloud is going to have the most powerful models behind the scenes because you really can select whatever hardware you want. Whatever's bright, new, and shiny, you can integrate that in the cloud very easily. But we're also spending a lot of time developing models at Ephesoft that can be shipped out to less powerful hardware systems, especially smaller on-premise solutions. I mean, as Kevin was mentioning, just think about the things that run on your phone. If you have an Android and you've ever taken a picture in portrait mode, behind the scenes is actually an incredibly powerful convolutional neural network that's producing those really high quality photos. And if it can run on a phone, we can take equally powerful and even more powerful models and run it in an on-premise solution simply by taking a few tweaks here and there. It won't be as powerful as a fully GPU-supported model, but the trade-off is that it can run on much more restricted hardware and still provide very excellent state-of-the-art results.
Okay, all makes sense. Move on here. So I thought this was interesting. You hear about some of the resistance to the cloud and putting data up there. I think it's pretty obvious that some of the big cloud providers like AWS, Microsoft, they're really sparking this move to the cloud for these types of solutions. And obviously we've jumped on that wagon as well with AWS. So we talked about heavy infrastructure. We talked about the complex projects that data science teams required. So I'm thinking to myself, just how available is AI? And it seems like it would only be available to large businesses that can afford the data science teams and the hefty budgets that come along with it. Kevin, what do you say to that comment?
Yeah, that might have been true, a decade ago. But with the advent of, software as a service, AWS and Azure cloud services, and this transition to, the pay by the SIP, the need to make these huge capital expenditures to get access to this technology is just not there anymore. I mean, any company, no matter the size, can get access to these specialized kind of point solutions and, start leveraging them within their organization and without the major capital expenditure. So I think that's where the cloud and and SaaS is just kind of revolutionized how you approach enterprise software and get access to it.
And David, this McKinsey report that I pulled up on AI adoption, you can see there's a ton of different things that are preventing adoption. You have any comments on that?
Yeah, I've got a lot of comments, so buckle yourselves in. So as Kevin said, right, it's not so much budget anymore, but there are a lot of considerations to take into account. And as you look over this, what's preventing adoption, this really does reflect reality coming from experience here. I've worked bringing machine learning solutions into a variety of industries, ranging from healthcare to photography. And the only thing I'd really change about this is the order of some of these individual components. So all of the data problems I'd actually lump into one, and it's largely just a lack of understanding of data. Sometimes when people or companies are ready to get into the machine learning, artificial intelligence area and bring a project to life, they have the wrong type of data, or they don't have enough data, or sometimes they have too much data and they don't know what to do with it and they have no way to interact with it. And so really the problem is that no one understands what they actually need in hand before tackling the project. They'll hire a team just to find out that they're actually not in a position to utilize machine learning at that time. They should have spent the previous 2 years prepping before hiring, and 6 months later, they've sunk $500,000 into a project just to realize that it's not going to be possible, at least not in the short term. And that's also compounded by a lack of talent. It's the second bullet point up here. I think that's exactly it. More analogies. A lot of people can hammer boards together with a hammer and nails, but not everyone can build a house end to end. And there's just a huge pool of talent right now who have gone through online courses or boot camps, and they're taught skills that would work well at Google or Facebook or Microsoft, where they can recognize what's in an image, a cat or a dog or a car. They can find a pedestrian for self-driving cars. They can turn your voice into text, really the big things that everyone is focusing on. But as soon as you get data in an unexpected format, for example, a data cube for geophysical applications, or your task is different. You're not predicting what's in an image. Suddenly you have to make complex decisions based on these weird data formats. Suddenly your talent pool shrinks really, really quickly because you have to fundamentally understand the technology. You can't just do the math, which is good. You can't just do the code, which is nice, but you have to understand what the problem is, the nuances of the application, really all of the fundamental components of the technology. And there's just end to end. Right, end to end. And there's just not a whole lot of people that can do that. Even PhD students coming out usually focus in one area, which is designed to get them a job at Google or at Facebook. And so getting really widespread talent can be a difficult task for companies starting out.
Okay. Yeah, it's interesting. You hear about some of the projects where the data scientists are sitting around twiddling their thumbs because they don't have the data. So some interesting insight.
Right. And if you're looking to label data, a data scientist is of course the most expensive way to go about that. So it comes back, I think, again to the idea that there's just a lack of understanding of what's needed to start the project. Sorry to interrupt you. You may continue.
Sure. Oh, no problem. So here we are. That leads us to Ephesoft and accounting. So we've built this big, wonderful platform in the cloud, and we had a million choices for our first document AI solution. Kevin, so AP invoices is the first point solution we've built in semantic. Why invoices? Why was that the first path?
Yeah, let me give you some background on that, and maybe this overlaps a little bit with what kind of David was talking about. But one of the things you look at is, as an organization's trying to decide, where to invest their resources, and maybe an AI project to go focus on, you got to really focus on what would be very beneficial and have a strong ROI from investing in some type of automation or a digital transformation. And the reason that is one, you want your value out of it, but you at some point you have to justify the cost. And we know from enterprises have huge IT backlogs, and projects are all competing for different resources, and finding the people is really challenging. And so when you're trying to find that project, or at least when I am, I think about things like what are some tasks that might require searching across either many data silos or using natural language type querying, or you might have to answer questions that are difficult. Or what are some processes or a process that may evolve based on a specific set of rules and may be difficult to automate, because if you try to do that, you end up with this very brittle system. And as we looked out there, despite all of the efforts over the years, AP invoice processing is still predominantly a manual effort. And to do it, or users have to look in multiple silos. It's that to the most extent right now, it's still that swivel chair based automation where they're swiveling and looking at different screens to figure out what to do with this invoice. And so we thought that would be one that would have a good ROI, because we know from data that it's costly to manually process an invoice. And would provide some good value to the enterprise. And so that's kind of why we landed on this idea of in AP invoice processing as our first application within our platform.
Definitely a problem that's pervasive. David, can you give me a quick run through of how we process invoices with our AI?
Yeah, without giving away too many secret details, at a high level, we sort of dissect the invoice into multiple components in a bunch of different representations. And we're primarily considering two attributes. The first is the natural language processing side, where we have text. So invoices and documents in general are composed of a bunch of different values, words. And so we consider those. And then we also consider the visual characteristics using computer vision and convolutional neural networks. And then by breaking down these invoices into headers, addresses, tables, etc., it really gives us a holistic representation of the document and how it's structured and how these structures relate to each other. And then once we've analyzed, classified, and segmented out all of those components, then we stitch them back together in a format that could be sent to an ERP system. And then we also display that in a very visually beautiful way to the user, who can verify the results before sending it through the rest of the pipeline.
Okay. And we'll talk a little bit about some of your goals as we get to some of these later slides. But another statistic, I find this absolutely amazing here in 2020, that only 11% of AP departments have greater than 80% touchless invoice processing. I think of all the systems, the legacy capture systems that are out there, where users are still struggling with a big number of invoices, and that's just completely painful and what we're trying to fix. So we can help with that, right? Let's chat about how we approach the problem a little differently than some of the others out on the market. Kevin, how would you say we've approached the invoice problem differently?
Yeah, and I guess not to beat a dead horse here, when we look at, all of these digital transformation projects and automation projects that are, they're failing because they don't take, they still approach it like a data problem. Their goal is really just about getting data from one application to the next or one spreadsheet to the next, and they don't consider this productivity problem. And you can't solve that productivity problem with just the data. You really have to put the user and the worker at the center of that problem. And so I think what we've done differently is look at how we can leverage, some semantic technology to really free up the knowledge and make it available to the user, and recognizing that user can be both a human worker or a digital worker. And so I think that's how our approach has been a little bit different.
Okay, and David, your comments. What type of results are you looking for, and for you, what's success with the product?
Yeah, so there's a trend in the machine learning community, I think, where we tend to over-rely on a particular metric or loss function that purportedly is meant to tell us whether a particular model is good or not. So for example, if we're looking at accuracy and we have one model that's 90% accurate and another that's 91% accurate, it's easy to understand that because everyone knows what accuracy is. And so we say, well, the second model must be best. The problem is that that's actually not always the case, because the complexity of certain tasks in machine learning aren't really well represented by standard metrics. So as an example, let's say that a model is 99% accurate. The problem is that it's 99% accurate for every invoice that comes through the system. Well, that means that the user is going to have to intervene and fix every single invoice. 10 out of 10 invoices, they're going to have to go into and manually correct information. And that's actually not a great experience. But if we have another model, and say this model is 90% accurate, the thing is that it's 100% accurate for 7 out of 10 invoices. And that's pretty great because we've just alleviated 70% of the need for user interaction. So they'll only have to go in and fix 3 of those invoices, and the other 7 they can review and just click through. And that's what we try to focus on internally in our data science department, is not just a particular metric, but really a user experience focused metric. And so we've developed a lot of custom metrics that help tell us what is the user experience going to be like. How often are they going to have to intervene? How often are our results perfect? And so we really want to maximize the user experience, even if that means we suffer a couple percentage points in the more easily understood accuracy metrics and the like. And so at the end of the day, the user is what we're worried about.
That makes great sense. That's definitely a shift to a lot of the AP products that are out there. Interesting. Let's see. So, one comment I wanted to make is that a lot of the folks on the market, everybody can do easy invoices. And there's a broad number of products that actually do that. But it's those really hard, that 20% that are hard and difficult, that really make the product more effective and efficient for users. So I know that Amplify is one of the core pillars of context-driven productivity, or CDP, Kevin, and integration can really expand the productivity gains that an organization can glean with AI. How does integration play into the overall semantic product strategy?
Yeah, so one of the challenges that has resulted from kind of our legacy structure-based or this compartmentalized approach to data capture over the last few decades has been this kind of rise of the data silo. When data is locked away in the silo, it's hard, it's inaccessible, users can't get to it, and what you frequently end up with is more silos of duplicate data. We, as enterprises and technologists, we've tried a variety of approaches from, master data management to data lakes, and name the technology, but all we ever end up doing, it seems like, is moving the cost of how we manage that data from one resource to another. So to achieve true productivity, we really have to figure out how to make data available to the process and the systems that are going to need it, not only today, but tomorrow, right? So we're focusing heavily on, what you pointed out, and we call this amplify pillar, where, and within that, we're looking at how do you leverage semantic concepts like linked data and graphs to make the context not only discoverable, but also reusable. We're looking at how to make knowledge easy to integrate with, integration platforms and automation platforms like Power Automate. Bring it to the developers and the tools the developers are using. And all of this has to be done in this very secure, immutable way, to deliver this confidence in the data. So we're focusing heavily on, security from the ground up. Ultimately, this integration aspect is the key to, amplifying the value of that knowledge and making it available.
Sure, that makes sense. And obviously, Amplify is one of the pillars of context-driven productivity, which is kind of the whole theme behind acquiring documents, extracting that data, enriching it, and then sharing it, right? And that goes for both our products, Transact and Semantic. So, well, AI is really all about results, right? You want to spend all this money, implement, and get out there and see how it can impact your efficiency and productivity. So let's get to the heart of the conversation here, and I'd like to show where we are today with accuracy. And David, I believe we rate across these three core metrics for regular fields in Semantic, right?
Right, yeah. So we take into account the possibility of, getting the correct information, getting the wrong information, and missing information entirely. And so all of these numbers are balanced out across, different field types as well as different possibilities, so that we're once again focusing on the user, so that we're not focusing on something that we artificially kind of inflate a number that looks good, even if the actual result and experience is bad.
And these are out-of-the-box performance stats within our lab-based testing environment and things like that, correct?
Correct. Yeah, we've assembled a specific data set of representative invoices that we have on hand, and the model has never seen them before. And so all of these metrics come from sort of a blind test of the model to make sure that it's functioning properly. So this should be expected on any set of invoices, even the ones that aren't in our lab. But
interesting. And so, it's all about expectations. This is built to improve over time. I mean, will it eventually get to 100%? How does that kind of feedback loop process work?
Yeah, absolutely. So obviously, data is the lifeblood, as we've discussed. And so as we continue to integrate more data into our process, these numbers will continue to increase. Sort of the end goal of an artificial intelligence system is to meet or exceed human performance. And so ideally, and I think theoretically it's very sound, that we should expect our model to eventually reach parity with a human doing the same task. It's really a question of time. How quickly can we gather that amount of data? Every time that we add more, these numbers continually increase.
Interesting. Pretty impressive stats. And these are on just so everybody in the audience knows, these are on kind of the header-based fields of invoices. This is where it gets exciting for me because tables have always been really difficult in AP. They're where the majority of the time is spent correcting, validating, and these numbers really blow me away. So for folks out in the audience, we benchmark our product against, I won't say the name, but one of the biggest companies in technology. They have table detection algorithms that you can access through APIs. And they do really well, like I said, against the easy stuff. Everybody does, right? But in accounting, we typically see, over the years, I've seen customers, they spend 80% of their time on 20% of the hardest vendors, right? Hand keying information, but revalidating it. That's really the special sauce and the big differentiator, and usually a preventer of that touchless processing that we talked about. And one of the most exciting pieces. And so now that I've given you we've given you a broad overview of AI and machine learning, how we use it in semantic, the types of results that we're getting. I guess the next question is, we're there with invoices. What's next, Kevin? Kevin, you there?
Yeah, sorry about that. I think you stole some of the big thunder with the AI-based table detection and recognition, and that's coming out in our product now. Additional features, like vendor lookups, and ultimately, how do we automate that whole workflow and help companies really become productive? And so you'll continue to see features to support that rollout. We're working on API invoices and integrations with additional iPaaS and automation platforms. So there's a lot of interesting things going on specific to invoices within the semantic invoice solution. But from a vision and strategy front, we're starting to look at additional use cases. So what other productivity challenges can we begin to solve with the semantic platform, leveraging semantic technologies? And so I think there's a lot of exciting things to come. And the beauty of the new platform is the way it was built, leveraging modern SaaS and things like continuous delivery. You don't have to wait for huge releases like you might have in the past, and so you're just going to see this constant evolution and advancement of the platform.
That's great. And David, what's next for you? What's next in the AI?
Yeah, well, there's no shortage of things coming down the pipeline. Some of the things that we're really excited about is the use of graph neural networks for representing all of this interconnected and graph-based information. We're kind of in a renaissance right now of research into graph structures. I mean, you just look at Facebook and all of the various, Amazon shopping, how much of the world is represented by its relationships. And so integrating those kind of algorithms and architectures into our process, I think, is going to enrich our performance by quite a bit. Additionally, end-to-end table recognition. So obviously our tables are already beating state-of-the-art performance by quite a bit. We want to reduce our need for specialized components into one even better performing end-to-end architecture that blows the socks off anyone who gets to use it. And then kind of the third major area that's pretty exciting are self-improving models. So it doesn't make sense in an artificial intelligence ecosystem to continually have to fix the same mistakes. And while monthly updates that fix those mistakes are great, really what we'd like to see is after a series of corrections, our system will actually begin to learn from the user's interactions and correct those mistakes in real time. And so depending on the complexity, maybe it's just one or two invoices and the problem is solved. and it's perfect from there on out. Or if it's a really complex task, then maybe it'll be a dozen or 20 invoices. But ideally, we see a progression and a real-time evolution of the system as it's continually interacted with. The more you use it, the better it gets. So it's sort of the tagline.
Yeah, the ultimate goal, right? So, well, that's great. That's a great summary. And for the audience out there, we talked a lot and about our new platform, Semantic, and the invoice solution. You can actually check it out yourself. So if you go to ephesoft.com and click in the upper right, get a free trial. You can actually test it out and send your own invoices into the system and see the results right on the screen. So if you'd like to, definitely go do that today. And that brings us to questions. We've got a couple minutes left. Any questions from the audience out there? Let's see.
Looks like we have that one on, need to tune individual invoices. Did we cover that one well enough?
Actually, I'm sorry, I'm having some technical difficulties. Go ahead, Kev.
Yeah, I think there's, the whole goal of this is no. You should not have to tune every invoice. Ultimately, the system will learn as the more you use it. There may be times where you're going into a new region, or there's drastically different formats where you may have to do some retuning. But our goal is to make this work as out of the box as possible. And I think David and his team are spending a time on how to make the system kind of truly learn.
Yeah. And I'd like to.
I got another one. Oh, I'm sorry. Go ahead, David.
Sorry, I'd just like to point out too that we actually don't have any sort of fine tuning exposed. So in that sense, the user doesn't actually need to do anything to get those improvements. Whether it's a periodic update or an online update, that will happen independent of a user making changes. So there's no knobs or dials or switches that need to be continually updated by the user. That's all taken care of behind the scenes by us. Just another way that we're trying to make a seamless user experience and still get the best performance.
Okay. The other question I have is, do you have to use the application, or are there APIs to access the models? Kevin?
Yeah, sure. That's a great question. We are actively working on rolling out additional integration points. Today, you can access and process invoices as simply as sending an email. We're also, we got this idea of webhooks that would allow it to integrate with other systems. And we're rolling out APIs to allow easy integration into, some of the iPaaS solutions like Workato or Catalytics, as well as some of the automation platforms like Power Automate. So there's a variety of ways that you can get access and leverage the power of the semantic invoice solution.
Yeah, that's great. And I personally manage that integration effort from a business development perspective. So we want to make sure that you can use our processing capability from just about any application, any ERP, any workflow. The list goes on and on. So, well, we've got about a minute left. We're about out of time. So once again, if you want more information, deeper tech dive, you can go to ephesoft.com, contact us. You can also try out a free trial, and we'll be in contact to talk with you about your needs. So thank you so much for your attendance. And Kevin and David, thanks for your time.
Yeah, thank you.
Thanks for having us.
Take care.